All right, y'all. So the first three problems are basically graphing. So my number one, y equals 1/3 to the x. I'm gonna graph that on the calculator, and then we'll pick one of the four pictures here. So let's go to the calculator. All right, so go to y equals. I'm going to make it look like a fraction by hitting alpha y equals and enter. So I had 1/3, so 1/3. Then I'm going to arrow out, use my exponent key, and put in my x. All right, y'all, so that's one way to put this in there. The other way is to use parentheses and do 1 divided by 3, close parentheses, and then do your exponent and put in your x. Either way, you'll get this same graph. All right, y'all, so I'm going to hit enter on graph. And y'all, let me get my zoom set right. Let me go to zoom 6 so I can get a 10 by 10 graph. All right, y'all, so it comes down, and then it just sort of hugs that x-axis as it goes out. So we would look for the one picture. So y'all, we would go with D on that one. Now you can't pick B because B goes below the x-axis on that right side, and our graph never went below the x-axis, okay? So if you got a fraction, it's going to look like D every time. All right, y'all, number 2. So we got to tell it the graph we're starting with, and then what happens with this 1 being added. So when you add to the x, it moves it left. If you subtract from the x, it moves it right. So since we're adding 1 to the x, it's going to move me left. So I got to find the one that says left, and that would be C. And then we're starting with the graph of y equals what to the x? Well, you always want to put your base there, and my base is a 2. Okay, so I'm starting with the graph of y equals 2 to the x, and I'm going to shift it left 1 unit. So then you got to click on the graph down here. All right, remember the exponential tool is the second tool on the second row. So click that, click anywhere on the graph. It'll always start it in the same position. So we did horizontal left 1, so we would go to -1 on horizontal. And y'all remember down here where it says base, you got to change it from an E to a 2. You got to match whatever base you got on that, okay? All right, y'all, so you would save that and then go to the next question. So y'all, this is the same thing, except it's got 2 moves on it. So we're going to start with the graph of y equals, our base is a 2, so we would put a 2 there. Shift it blank 5 units. Since the 5 is being added to the x, that's going to go left. So just like the one before went left 1 because we added 1 to the x, this is going to go left 5. And then shift it blank 4 units. Well, at the end, if the 4 is being subtracted, it moves it down. If it's being added, it moves it up. So since the 4 is being subtracted, that's going to move me down 4 units. All right, then the same thing, you got to graph it. So pick your exponential tool, click on the graph. So we got 2 moves. We went left 5, so that'll be a horizontal to -5. We went down 4, so that'll be a vertical down to -4. And then remember, come down here and change that base from an E to a 2. All right, y'all. So the biggest place I get people on this problem is doing that base, okay? All right, y'all. So I'm going to go to the pad now. So the first three we're dealing with graphing, and I wanted y'all to see on the graphing that you got to change those bases, okay? All right, so I'll pick up on number 4. And number 4 is an investment problem. So $76,000 invested at 5.5% interest, compounded quarterly. So for part A, they want us to come up with the function for which the amount grows after t years. So we're going to find the function for which the amount grows after t years. All righty, so this is where they gave you the a of t here. And we got to fill in for our formula. So my first step, I'm actually going to write the formula here. We had P, which was our principal, times 1 plus R divided by N raised to the N times T exponent. R is the interest rate, N was the number of compounds per year, and T was our time. All right, so P, my principal, my starting amount was 76,000. Then we got 1 plus R is my interest rate. So that is 5.5%. That equals 5.5%. So I'll just turn the half into a 0.5. And you can get the decimal by just taking your fraction and dividing it, okay? So 1 divided by 2 gave me that 0.5. Now, to turn this into decimal form for my formula, I got to move that decimal left twice, which means I got to add a 0 so that I get a 0.055. So y'all, that is our R. N is the number of compounds per year. So do y'all remember what we said quarterly would be per year?
4.
And that'll be a 4. Good job. All right, then NT would be the 4 times T. Now, this is correct, but y'all, we got to go further and simplify the parentheses. So bring down to 76,000. We need to figure out what 1 plus 0.055 divided by 4 equals. So MathLab won't take it unless we simplify that, okay? So 1 plus 0.055 divided by 4, that simplifies to 1.01375. So y'all, you gotta change the parentheses to that and then bring down your 4t. Now MathLab will already have the a of t there. For a, you gotta put in that formula, okay? And then y'all, part B wants to find the amount in the account after T equals 0, 4, 5, and 10 years. All right, so I'll just put my times here. So when T equals 0, T equals 4, T equals 5, and y'all, T equals 10. Now you can do these one by putting a 0 in for the T and figuring out what you get, then coming back and putting a 4 in for the T, figuring out what you get. But y'all, when I got more than one value to pick, I usually just graph this in my y equals. And then I can get all four of these values really quick. So y'all, I'm going to go to the calculator. I'm going to go to y equals and clear that out. So my equation was 76,000 parentheses 1.01375 close parentheses, and then your exponent would be 4 times x. Remember, you got to use x on the calculator instead of t, okay? Now, what gets people on this problem is you got to have all these decimal places on the stuff inside your parentheses, okay? Notice I got 5 decimal places. Whatever you come up with on that part, you got to keep the whole decimal, okay? Now, y'all, at t equals 0 years, I know how much I got because I had 76,000 to start with. So at 0 years, it better be at 76,000, right? So y'all, we're going to go to second graph to pull up our table. And y'all, let me arrow up to 0 here. And these, they want me to round to the nearest dollar. So I can go with what's in the Y value here. But if it wanted to round it to the nearest cents, you would highlight the Y value. And if it had a decimal, it would put it down here where this Y1 equals is, okay? But these ones came out perfect. So at 0 years, I had $76,000. Now let's go to 4 years. So I arrow down to x equals 4. Now y'all watch this one. If I wanted decimals, there's my decimal. When I click on that 94,560, it gives me the decimal approximation. But y'all, like I said, this one don't need decimals. It needs the nearest dollar, which is what's showing. So for 4 years, we got 94,560. So then we go to 5 years. At 5 years, we got 99,869. And y'all finally was not 10. So let me arrow down to 10. And at 10 years, I had 131,235. So y'all, really, the calculator is the quickest way to get these amounts, okay? But like I said, you can do them individually and put the numbers in for those T. So we had the one where we had to come up with the formula and mark it. Number 5 is using the same formula, but we're going to work an actual problem. So this one says Melissa's 6th birthday. She gets a $2,000 CD that earns 4% interest. compounded semi-annually. So 4% interest on a 2000 CD compounded semi-annually. They want to know how much is available if it matures on her 10th birthday. All right, so you gotta figure out your formula and then plug in all your values, okay? So still using the formula we had here. Um, we're finding A of T. Well, T is how much time passed. So we got to figure out the T. It matured on her 10th birthday. She got it on her 6th birthday. So the difference between her 10th birthday and 6th birthday was 4 years. So we're finding the amount after 4 years. All right, y'all. Our principal was our starting amount, 2,000. Then we got 1 plus R. R is the interest rate. So remember, that's 4%. Turn that 4% into a decimal. You move it left twice. So y'all, looks like we got to add a 0 so that we get a 0.04. So it'll be 0.04. So y'all, what is compounded semi-annually? How many times would that be a year?
2.
So that'll be a 2. And then I got 2 again times t, which we said was 4. So my exponent will be 2 times 4. So y'all, I'll just plug this one in since I'm only finding one value this time. So I'm just going to go to the calculator. Now this one, we got to round off 2 decimal places, okay? So let's go punch it in. Oh, y'all, so we had 2,000, parentheses, 1 plus 0.04 divided by 2. Close the parentheses, and then your exponent is 2 times 4. Oh, y'all, so remember, we're rounding at 2 decimal places. So that looks like $2,343. And what's that going to be? 31 with an 8 after it. So we'll make that a 32. So 23, 43, 32, okay? All right, y'all, at number 6, we start finding a bunch of logs. And most of these logs we can punch in the calculator if we want to, okay? So this one says find the logarithm. And they got log base 10 of 0.1. So the log base 10, you can use the log base in the calculator if you want to. But if you remember, the log button that's on front of the calculator is a log base 10, okay? So I'm going to show you two ways to do this one. You can use the log base, the log on front, and just put in 0.1. This one's understood to have a 10 there, and y'all would hit enter, we get -1. Now, the way I'm going to do most of these is doing the log base by hitting math, arrow down the log base, hit enter, and then here you can actually put in the 10 if you want to, and then do the 0.1. But y'all look, no matter which way I do it, I get a -1 on that, okay? So we got -1 on that one. 7 wants me to find the log. And y'all, they're giving me a log base 4 of 4 squared. Now I'll do this one on the calculator, but we learned last week that if we got a base of a logarithm that matches the base of the result raised to an exponent, this answer in the long run will be the exponent. So we should get a 2 on this one, okay? But y'all, I can punch that on the calculator using my log base. So to get log base, I hit math. I'm going to arrow down and get that log base. Hit enter. So the base was a 4, and then arrow right, and the result was a 4 squared. So that'll be 4 exponent 2. So y'all, we can make these look exactly like the problem. Let's hit enter, and we get that 2 like we said, okay? So y'all, if this base matches the base of the result raised to an exponent, the answer is always that exponent, okay? All right, y'all, 8 is another one. Find the logarithm. And y'all, I'm really focusing on that calculator today, because I want y'all to see pretty much every problem I've done can be done on that calculator. All right, y'all, so 8 was find the logarithm. Log base 81 of a 3. All right, y'all, let's come set on the log base. All right, so I'll clear that one out. Gonna grab a log base. So math and arrow down, enter. So the base was the 81, and then arrow right and put in your 3. So log base 81 to 3, hit enter. Now y'all get a 0.25. MathLab don't want decimals, it wants fractions. So to turn a fraction from a decimal, you hit math and then enter twice. Enter, enter. And you get a 1/4. Y'all think number 9 is another one? Find the logarithm. So this one has a log base 7 of a 1. And y'all, we had a property on this one too that said no matter what this base is, If that result is the 1, then what's the exponent have to equal? So why don't one of y'all punch this in and tell me what the log of a base 7 of 1 equals?
Zero.
It equals 0. So y'all, no matter what this number is here, if that's a 1, you better put a 0 for that answer. And y'all, most of y'all's, I'm pretty sure everybody's number 9 will have a 1 here, okay? The only thing they're changing on number 9 is the base. So pretty sure everybody on number 9 better get me a 0 there, okay? Alrighty, y'all. So at number 10, they started having us change from exponential to a log equation. So we're going to convert to a logarithmic equation. So they're giving me 10 squared equals 100. So all I got to do is rewrite this from exponential to logarithmic. So if we're going to write it as logarithmic, first step is to write log. Then we got to figure out the base of the log. Well, the base of the log is the same as the base of the exponential. So we get a log base 10. The result of the log is the result of the exponential, which is 100. Because y'all remember, the logarithm equals the exponent, which is 2. So this is what we want in MATLAB. Okay, so just remember, convert it the same way I did. You're going to put your base here, your result here, and then your exponent right there, okay? And y'all, if you want me to put the actual process, I'll do that right here. Log base A of y equals x if and only if A to the x equals y. So this is the logarithmic form. This is the exponential. Everything moves the same way I moved it. The A, the y, and then the exponent, okay? All right, so number 11 is convert to logarithmic equation. So two of these except this one, they're using e squared equals m. So I'm going to do the same conversions. I'm starting with this side, I'm going to turn it into this side. So write log. All right, E is where the A is, so E becomes the base. M is where the Y is, so Y is my result. And then the 2 is where the exponent is, that becomes my exponent for my answer. All right, y'all, so that's the trick on those two is just to rewrite them, okay? All right, y'all, so let's see. So it looks like 12 and 13, we're going to convert into exponential. So we'll start out with the log and turn it into the exponential, okay? So just remember, this is logarithmic. And then this side is exponential. All righty, y'all. So let's see. For number 12, they gave me log 6 of 36 equals 2. All right, so notice the 6 is where the A is. That becomes the base. So 6 is my base. To get that exponent, we get the exponent of the logarithmic, which is the 2. And then that's going to equal the result y, which is the number after the base. So y'all, these ain't bad. You're just converting out of one into the other, okay? And we know 13 is going to do the same thing. Convert to exponential. All right, y'all. Log base A of M equals negative Y. So this M has to be capitalized on your answer, and the A and Y have to be lowercase. So you got to put them exactly like they look on theirs, okay? All right, so A is the base. So I'm going to have A. The exponent is the negative Y. And that's going to equal the result, which is the capital M. Okay, y'all. So remember, just use this. This is the conversion right here. So these 4 problems, 2 of them went that way, and then 2 of them went that way, okay? All righty, so then they wanted us to start using those calculators. So for number 14, use a calculator to find a natural log. ln of 326.1. Now, you got around this 4 decimal places. Now, you got an ln on the front of that calculator. So, y'all, I'm going to go to the calculator. Let me clear everything. You got an ln to the left side of that 4. So, hit ln and then put in 326.1 and enter. All right, y'all. So that's a 5.787. The 4th decimal place is a 2. It's got a 0 after it, so I'm going to keep that a 2. So I got a 5.7872, and there's my 4 decimal places. Now this one says find the log using change of base. Well, for us, that means log base on the calculator. Okay. So 15, we use the log base that's on the calculator, and we're finding the log base 4 of 17. And y'all, we're going 4 decimal places. So let's see. Do any of y'all got your calculator? Punch that in and then chat me what you get for that. And round it 4 decimal places, okay? I think you got it there. So what's that? 2.0434? And y'all, all she did was what? Come to the calculator, went down with log base. You had a base of 4. Result was 17. And enter. Oh, I think you meant the 7 there. Looks, I'm getting a 2.0437. But y'all, that's all you're doing. You punching in answers on that calculator and it'll spit out these. And then you just round them out 4 decimal places, okay? All right, y'all, 16, we start dealing with those properties. The product rule of logs, the quotient rule, the power rule, and all that fun stuff. So 16, they want me to express as a sum. Well, the only rule that I had that expressed as a sum was the product rule. And remember, the product rule said log A of x times y equaled log A of x plus log A of y. So if they want me to express it as a sum, that means they're giving me a product, okay? And y'all, they're giving us log base 11 of 11 times 121. And all they want me to do is this right here. So you distribute the log 11 to both of the factors and put a plus sign in between them, okay? So log 11 of 11 plus log 11 of 121. Yo, I don't want you going no further. That is the final answer. If you've gone further, then you're not expressing it as a sum, you're evaluating it. They want you to stop at this point right here, okay? All right, 17 said express as a product. Now, the only rule we had that expressed as a product was our power rule. So if I had log A of m to the n, this is where we brought the exponents down and wrote it as the n times log A of m. So when you express it as a product, you're just bringing the exponent down and writing it as a product, okay? So this one, they're giving me log m of t to the 7th. Now, they actually put the exponent inside the parentheses, but it don't matter. We're still going to take that exponent and bring it down to the front so that we get a 7 times the log m of our t. Y'all, they don't want me going no further because now it is expressed as a product. Okay, so don't go no further than they want. Just do what they're saying and be done with those two, okay? All right, y'all, 18. We're going to rewrite these as sums or differences. And on these, we got to go until we can't go no further. So they're giving me an ln of parentheses x to the third, y to the third times z. Now, I ain't going to lie on this one. The only difference between my number 18 and your number 18 are these two exponents are going to be a different number. That's the only difference. You're going to have an x, y, and z like me. You'll just have different exponents probably. But since this stuff is all being multiplied, we're going to write it as sums. Okay? So we're going to distribute the ln to all three factors. So I get an ln of x to the third plus ln y to the third plus ln of the z. So products are written as a sum. Now, y'all, we're almost done. But since we got exponents on two of these exponents have to be brought down to the front. So that this one will give me a 3 ln x plus, bring down that 3, I get a 3 ln y. And then this one only has the exponent of 1, so that don't change nothing. So bring down my ln of z. Okay? And y'all remember, in math lab, that's a little L and a little N. That is not a capital I, okay? It's a little L.
I have a
Hey,
question.
y'all, so that was number 18, so that's what they want right there, okay?
I have a question.
I hear you.
If we put the letters like the X in parentheses, will it be wrong? I'm just
If you
wondering.
do it like this, it should take that.
Okay. Okay, that's what I wanted to know.
If it marks that wrong, I'll change it.
Okay.
Okay. So y'all notice this one said sums or differences. So it was one or the other. 19 says express as sums and differences of logarithms. So this one we're doing both of them. So we got a log base b. And y'all, this one has a fraction. I got a p to the fourth, q to the seventh over m to the fifth, and a b to the eighth. And y'all, I'll tell you this, what I do to this one, y'all's will be the same other than the exponents again. There's nothing they can do to these problems other than change their exponents, okay? But this is where The two factors that are on top, we write as positive, and the two factors on the bottom, we write as subtraction, okay? Now we got to distribute the log b to all four of these. So we'll do a log b of p to the fourth plus a log b of q to the seventh. So that takes care of my top. Now the other two factors are coming from the bottom. They get subtracted. So that'll be minus log b of m to the fifth minus log b of b to the eighth. Now, exponent's got to come down. So we're going to bring the 4 down. We're going to bring the 7 down. We're going to bring the 5 down. But y'all, what's this equal? A log b of b to the eighth. So remember, I got a base of the log that matches the base of the result raised to an exponent. This whole thing right here equals 8. So for final answer, bringing the 4 down, I get 4 log b of p plus bringing the 7 down, 7 log b of q minus 5 log b of m minus, remember this whole thing equals 8 at the end. Y'all listen, the only difference on my problem and yours are going to be these exponents. But you're going to get some number log b of p. You'll get some number log b of q. You'll be subtracting some number log b of m. And then you'll be subtracting whatever number at the end, okay? Your answer will look just like this, other than them 4 numbers, okay? And y'all, I just want y'all to really start seeing the similarities on these. Okay? There's not much we can do to these to change them up other than what, a few exponents and stuff like that, okay? On 20, they want us to start simplifying. This one has the ln of x squared plus 7x plus 12 minus the ln x plus 4. All right, y'all. So the trick on this one to start with was to write it as a single logarithm. So the plus factors go to the top, and since this one's being subtracted, I write it as a quotient. So you're going to pull out the ln, the x squared plus 7x plus 12 goes on top. On bottom is the x plus 4. All right, next we're going to factor the top. Now the bottom we cannot factor. That's just an x plus 4. We cannot do nothing to that. So the bottom has to be an x plus 4. Now y'all watch this. There's an x squared. That's going to be an x and an x. If this is going to simplify, one of these factors better be a 4. So family factors of 12, that equals 7. Well, that'll be a plus 4 and a plus 3. So whatever you get on bottom, one of these two factors will equal that bottom factor, okay? You're going to cancel them out. And your final answer will be the ln x plus 3. On this answer, you must keep the parentheses. Okay? If you don't, it'll treat it like an ln of x plus 3. It won't be doing the ln of the x plus 3 altogether, okay? So keep your parentheses on this one. Now, y'all remember, if you have trouble factoring, graph y1 equals x squared plus 7x plus 12. Y'all watch, if you've got factoring issues, remember, we can solve all these quadratics by graphing. So let me punch that in. X squared plus 7x plus 12. I'm going to graph that. And you can tell over here at -1, -2, -3, it crosses. And at -5, it crosses. But y'all remember, those are the zeros. And the zeros are always opposite sign than the factor. So when you graphed it, we got x equaled -3, x equaled what, -4. Just remember, when you're graphing it, these are the zeros. They always have opposite signs than the factors. So you got to make the 4 positive and the 3 positive, okay? When you put them back in factor form. All right, y'all, so looks like we're on number. Oh, y'all, break time though. Break time, break time. So let me stop my share real quick. Let me pause this. All right, y'all. So we are on 21 now. So this one says solve for x. And they're giving me 5 to the 9x equals 25. So this is an exponential equation. So my first step is to see if I can rewrite both sides using the same base. Well, 25 equals 5 times 5. So that equals 5 squared. So I'm going to rewrite the 25 as a 5 squared. So I got 5 to the 9x equals 5 squared. So that's your first step, is you're going to rewrite the right side using the same base as the left side. At this point, your bases match. So since the bases match, that means the exponents are equal. So 9x equals 2. And y'all solving that for the x? I'm dividing both sides by 9. So that cancels, giving me my 1x. Can't do nothing to that side. So that equals 2 ninths. Okay? So 21, you are going to be able to rewrite it just like I did mine, okay? Now, 22, on number 22, we're solving for x. But you're not going to be able to rewrite this one. So this has the 3 to the x equals 10. So we cannot rewrite 10 using 3 because 3 times 3 is 9, times 3 is 27. So this one you can't rewrite. So since I can't rewrite this one, I'm going to take the log of both sides. So the log of 3 to the x equals the log of 10. Y'all are going to do the same thing. You're going to take logs of both sides. That way you can bring that exponent down using the power rule. We're writing it as a product. X times log 3 equals log 10. And then our final step is divide both sides by the log 3. So those cancel, I get my X. And we're going to have to approximate this 4 decimal places. Now in the calculator, you gotta close these parentheses on the logs, okay? All right, y'all, so let's go punch that in on the calculator and see what we get. I had a log of 10, so log 10, close parentheses, divided by log 3, close parentheses. All right, we're rounding at 4 decimal places. So 2.0959. I'm gonna keep that a 9 because it had a 0 after it. All right, y'all. So y'all just gonna be the same thing. You're gonna take the log of the right side, divide by the log of that number on the left side, okay? All right, 23, solve for x. Basically, all the rest of these are solving, okay? So 23, I got a log base 3 of 2x minus 7 equals 1. All right, so on this one, I've got a single log on one side equal to a number. The only thing you can do with this, when you got a log on one side equal to a number, is rewrite as exponential. So these doing them problems, I think, was like around number 13 and 14. The base is 3. Exponent is 1. And that equals the 2x minus 7. All right, so 3 to the first is 3. All right, y'all, to finish solving this, we need to solve for x. We're going to add 7 to both sides. So I get 10 equal to my 2x. Then divide both sides by 2. Well, that cancels, giving me a 1x. And y'all, 10 divided by 2 gives us 5. And then I can keep that answer because it makes that all positive, and I'm able to take a log of a positive number, okay? So you're 23, you're going to do the same thing. You're going to rewrite it as exponential, and then you're going to solve for my x's there, okay? So 24, they're doing the same thing, but they're going to give us more logs on it. And y'all, let's see, 24, they give me 3 logs on this one. Log base 4 of b plus 14 minus log base 4 of b plus 6 equals a log base 4 of a b. Alrighty, so you got two logs on the left side. We need to combine them into a single log. Now, since this is being subtracted, we're going to write it as a fraction, okay? So bring out the log 4. The b plus 14 goes to the top. The factor being subtracted, the b plus 6 goes to the bottom. And then that's going to equal the log base 4 of a b. So let me show you what we got. We got log bases on both sides that match. So your log bases match on each side. So since they match, that means the b plus 14 over b plus 6 has to equal that b. Now, I don't know about y'all, but anytime I got a fraction like this, I make this side look like a fraction. And I'm going to solve this one by cross multiplying. You take both of these times the 1. So b times 1 is b plus 14 times 1 is 14. Then you cross multiply both of these times the b. So b times b is a b squared plus 6 times b is a 6b. So y'all notice this one. You got a b squared term in here. So this is quadratic. So we need all this stuff moved over here because when you got a quadratic equation, you need a 0 on one side, okay? So I'm going to subtract b from both sides. I'm going to subtract 14 from both sides. So add the opposite of both of these to both sides. So now you got a 0. This side will give me a b squared. 6 minus 1b leaves you 5b. And then bring down that negative 14. At this point, I'm going to factor, but I will show you how to do this one on the calculator also. So the b squared will be a b and a b. Now, last one's negative, so your factors will have opposite signs. I need factor to 14, that'll give me 5. So that'll be 7 and 2. The 7's positive like the 5, and the 2 is negative. So y'all remember my last step now, set both them equal to 0. So here I'm going to subtract 7. I get a negative 7. Here I'm going to add 2. And I get b is a positive 2. So y'all, let me show you this. At this point, the b squared plus 5b minus 14, I'm going to show you how you would have got these two answers factoring, okay? By graphing. So I'm going to go to y equals, clear that out. All right, so this one was b squared, so I'm going to use x squared plus 5x minus 14. So remember, you got to use x's on here instead of b's and whatever else they give you. Now we're going to go to the graph because we're looking for the x-intercepts. Well, it looks like on the right side, I got a +1, +2. Well, we got b equals 2, so 2 is one answer. And then if you go left, -1, -2, -3, -4, -5, -6, -7. So there's your two answers. And if you look on the table, there's a 0 at 2. And then if we go to -7, we get a 0. So either way gets me those two answers, graphing or factoring, okay? Now remember, since I was actually solving equations, I don't have to change the signs like I did when I was putting them into factors, okay? But y'all listen, both of these numbers ain't my answer. Because since I'm dealing with a logarithm equation, remember, you cannot take logs of a negative number. If you put a -7 in for that b and do a log base 4 of -7, you're going to get an error message that tells you it's a non-real result. So if you get a negative answer and a positive answer, you gotta get rid of the negative answer. And our only answer is the 2, okay? All right, y'all. One more to go. And this will be number 25. And it is another solve. So this one we're going to solve log base 2 of x plus 3 plus log base 2 of x minus 3 equals 4. So it's a little different than 24 because they didn't put a log on the right side. But I got two logs on the left side, and we got to combine these as a single log. Now, these ones are being added, so to write them as a single log, they're going to be a product. So bring out that log base 2, and I'll have x plus 3 times x minus 3, all equal to that 4. And y'all, I'm actually going to FOIL this stuff. And I don't have to do the long FOIL on this because they're conjugate pairs. So all I got to do is the x times x, which is a x squared. And then 3 times -3 is a -9. All equal to 4. So we can shortcut FOIL because they're conjugate pairs. Because y'all, if you FOILed it out, this 3x and that -3x, they're going to cancel anyway, okay? So at this point, you got a single log equal to a number. So you're going to rewrite as exponential. So my base is the 2. The exponent is the 4. And that's going to equal the x squared minus 9. Hey, also 2 to the 4th is 2 times 2 times 2 times 2, which is 16, equals x squared minus 9. Now, y'all, usually on these, I would add 9 and take square roots on it. But I'm going to show you another way. I'm going to subtract 16 so that I get 0 equals x squared minus 25. So I'm going to solve it by factoring. Then I'll show you how you could have square rooted it or you could graph it. At this point, we could graph that and get the two answers. So x squared is x and an x. Now, when you don't have an x in the middle and you got a number at the end like this, one's going to be plus, one's going to be minus. And then you take the square root of 25, which is 5 and 5. So remember, it's negative at the end, so you got unlike signs. And y'all finishing it out, you set both them equal to 0. Subtract 5 on the first one. Add 5 on the second. So that's one way to solve it. Y'all, another way at this point right here, when I had 16 equals x squared minus 9, I could have added 9 to both sides and got 25 equals x squared. Then I could have done the square roots of both sides. So that gave me x. This would have gave me a plus or minus square root of 25, which is 5. So you could square root it, you can factor it, or at this point, when you had the x squared minus 25, we could have graphed it. So clear that out. X squared minus 25. All right, graph it and see where it crosses the x-axis. So y'all to the right, that's 1, 2, 3, 4, 5. To the left, -1, -2, -3, -4, -5. So -5 and 5 were the solutions to that. But y'all guess what? We got a logarithmic equation. I cannot take the negative answer again. And my only answer is x equals a +5. Okay? Just remember, no matter how you solve it, you cannot keep that negative answer, okay? So that our only answer this way would be 5 also. All right, y'all, so don't go nowhere yet. I got to do something. All righty, so let me stop that share. Oh, well, let me write this real quick. So on your chat, if you want 5 bonus points for test 4, on your chat, let me know you want the points. All right, so let me get these names. Johnson, Katerica, Aaron. All right, y'all. So chat me if you want bonus points. I got Johnson, I got Hussey, and I got Farrow. So y'all getting rewarded for staying around with me today, okay? And y'all, I'm gonna tell you what I'm gonna do on this one. Since y'all the only 3 that are responding to me.
I'm on here and I tried to respond. This is Monica.
Okay, Monica, I got you. Okay, Monica, Brewster. Anyone else? All right, well, y'all guess what? I'm doubling those to 10 bonus points.
Yay.
So, y'all, that's a whole letter grade almost. All righty, y'all. So, y'all, the main thing